the database design that caused any speed or any performance issue, there might be the redundant information. So we'd like to remove such information. So how? Through the normalization process. I think that we are going to have the final exam, the Thursday 1:30 to 1:45 to 3:45. So this is the assigned schedule. So I cannot change it. I cannot have the makeup exam. So please check your schedule. That should not be duplicated with other class schedule. Okay. So if you have any duplicated schedule, you need to contact the other professor who moved the final exam schedule, because it's assigned by the registrar office. Okay, and
after that, June 9th.
I think anyway the final exam week Thursday. I cannot remember the date, and so May. Which date?
It's Thursday 9th.
Yeah, Thursday. It's May 9th? Yeah, okay. So Thursday, 1:45 to 3:45, 2 hours exam. And then the as before final exam, I tried to complete everything for grading and including your project, including your assignment, everything will be completed. Then final exam will be added to my score sheet. Then your final grade will be determined. This is my policy. I never ever consider the promote or upgrade of your final grade because of your personal reason or the problem. Like I need to get a B+ to continue my scholarship. Right? Yeah, I understand the situation, but I cannot change your grade because of that such a personal reason. Even sometimes you need to keep the average GPA like the B 3.0 to continue the visa or whatever. Even that time I cannot change. Okay, if you are really serious about your everybody's serious. Everybody wanna get the higher grade and the better grade, but I definitely cannot consider. There is no excuse. The only exception is the doctor's letter or the doctor's notice in case you cannot take the final exam, or in case you cannot complete your class activity because of your illness or the medical problem, you or your spouse. But the other, no exception. Even though I have heard so many times my relatives died, so I got depressed, whatever. That's I understand personally, but I cannot excuse your personal situation. Okay, please do something right now. So like you still have a chance for the project B and the final exam and some other class activity. Okay? So from time to time, I'd like to give the chance to get the extra point. If I have a time, I'd like to give the chance to answer or whatever. Okay? So right now we are doing the normalization process. The main purpose of the normalization, as he answered, is we'd like to make our initial database design better and better. In other words, is there any goodness measure? Can we judge whether this is good or not? At that time, the first thing you need to keep your mind is the redundant information. So based on that, we have discussed about the informal guideline. Guideline 1, guideline 2, 3, and 4. First guideline, can you remember that? It's a one meaning for one relation, one table. That's obvious actually. So if we keep the student information, professor information, staff information, all the employee information, one table, that will be messed up, right? It's not easy to manage. So the ideal case is, why don't we keep the one meaning in one table? That's obvious. That is the first guideline. The second guideline is no anomaly. So such as insert, delete, and update anomaly. What is the anomaly? For example, I'd like to delete the data, just one department. But if your database is not good enough, then the other data, employee data, will be deleted. That is called the deletion anomaly. Similarly, insert anomaly and update anomaly. So if your design does not cause any problem of the anomaly, it's good. That's the second guideline. Third guideline is less null as possible. It's not possible null-free database design. So null is one of the ways how we can design the relational database model. Okay, but if you have too many null, that may cause the performance degrade, even waste of space. Okay? The last guideline is join operation. If your design is not well organized, in other words, sometimes the one table have the two more in the meaning, or sometimes the one meaning is decomposed. At the time when you join the table, so it may cause the unexpected data. Okay, that is the first guideline. If you avoid such unexpected data of when you join, that is good the model. But so far we have discussed about such a goodness measure. Right, description. Just describe. I describe. You describe such a thing. It's an informal definition. What if we define such a guideline using the mathematical approach? In other words, can we describe such a guideline using the equation or something mathematical term? That is the functional dependency. Last class we have discussed about the functional dependency. What is the functional dependency? Pfizer Arcadi? No? Manner?
Yeah.
Yes. What do you think? What is a functional dependency?
It's, we need to describe. We need to find the minimum function dependency.
Minimal function. Yeah. What does that mean? Functional dependency. Just explain with your own word. Or example.
Measure.
Measure.
No, to find the
So for example, if you know the social security number, you can identify one person, right? Because ideally, theoretically, social security number is unique number. Actually, actually there might be duplicated social security number in the United States. Yeah, using that attribute or sometimes set of attribute can determine. In other words, using this set of attribute, you can find the other attribute. You can identify the other attribute or attributes sometimes. Okay, that is a functional dependency. So if we can identify all such a functional dependency, we can easily classify group by the same meaning. Okay, then we can pursue the first guideline. First guideline is one meaning. Yeah, I understand what does that mean. What the meaning means. Okay, you know, but mathematically it's a little bit ambiguous. What does that mean? The meaning. Okay, so to define such a thing, we are going to use such a functional dependency. Why don't you go back to, why don't you remind the high school or the middle school or elementary math? At that time you learned about the function. A function is a set of x value. Okay, using a set of x value, you have something matched set of y value. So sometimes we can use y equal f over x, or sometimes y equal x squared plus whatever. There are a bunch of functions. Everything actually that you learned so far is kind of a function, equation. Then using that, so far you are using such an equation or function in your research also. If you are taking the electrical engineering or some other courses, even the computer science course, you learned a lot of function, equation. That is a formal definition, formal approach to define the problem. Then you solve that problem, then apply to the real application, like the program or the device or circuit. Okay, that's the same thing. So how can you define such a meaning. So using the functional dependency. So functional dependency is the function. A group of a set of attributes define a set of attributes. How many? How many functional dependency can you find from one table?
One.
Many. Right? It's not infinite, but you can find many the functional dependency. For example, think about the employee. Employee, what is the primary key? It's a social security number. Social security number identify first name. Social security number identify middle name initial. Social security number identify other attribute. Also, social security number determine first name, last name, address. Social security number determine a bunch of different functional dependencies. Also, social security number plus address can determine first name. That makes sense because you have the social security number. So there are many functional dependencies. So it's very complicated. What we need is core functional dependency. In other words, it's a minimal functional dependency. So today we are going to learn how to find minimal functional dependency. That minimal functional dependency or core functional dependency is the most important one. The other, actually, we don't need. So, in this case, for example, sometimes we can use the arrow to represent functional dependency. For example, social security number determine e-name, social security number determine birthday, social security number determine address, and so on. We have another functional dependency group like the D number determine D name, D number determine D manager social security number. From this EMP underbar DPT table, how many minimal functional dependency can you find? So we do not define the minimal functional dependency yet, but minimal functional dependency usually left-hand side is only minimum set of attributes. It can be social security number and B-date, but it's only social security number. Okay? We will define the formal later, but in this case, social security number determine the other. Also, we have D number determine the other. So there are two minimal functional dependencies. Okay? In other words, there are two meanings in this table. So that is the reason this is not a very good database design. As you can see, it has the employee information as well as department information. Okay? So, in other words, it has some redundant information. It may cause some problem later when you implement the database system. What about this one? This is the example of the EMP underbar project table. When you see the EMP underbar project table or relation, you can identify three minimal functional dependencies. One is social security number determine the e-name. That is related to what? Employee information, right? Another one is project number determine project name, project number determine project location. That is related to project. The third one is social security number plus P number. The project number determine hours. That is related work zone. So there are three functional dependencies. Actually, the minimal functional dependencies. Okay? In other words, there are three meanings. In other words, that one table has three different meanings. It's a redundant. So that may cause something problem. Anomaly problem, also some other problem. So we try to address that problem. We have discussed about the solution. How can we resolve such a problem?
You compose the table. Each relation.
We can separate, okay, by the meaning, by minimal functional dependency. It's a decomposition. It's a segmentation. The names are various, but it's the same process. So we can segment by the minimal functional dependency. That process is called normalization. There are different levels of the normalization. The first one is unnormalized one. we don't care the normalization, dependency problem, just put all the information in one table. That is unnormalized. Then next, first, second, third, and so on. We will see such a level, different levels of the functional dependency today. First, this is the example of a functional dependency. However, you can find many functional dependencies. So first, there are some inference rules. Inference rules are not the rocket science. It's not the Nobel Prize work you learned in your math class in elementary school level. So like the reflexive, for example, X is a group, X and Y are group of attributes. For example, just think about the example. X is a social security number. Y is first name, last name, middle name, initial, and address, something like that. So Y is a subset of X. That means Y is a subset of X. So social security number plus UBID. And Y is UBID. Definitely X determines Y because Y is a subset of X. Okay, it's obvious. That is called the reflexive. Augmentation and transitive. You can understand easily. Using this inference rule, you can prove the many others like the decomposition if X determine Y Z. In other words, social security number determine first name, last name. That means social security number determine first name and social security number determine last name. So these are the obvious. Using this one, actually we can define the closer. If you are taking the not freshman level, I think the sophomore or junior level college math, in math department, you can learn the set theory. In set theory, there is a concept of closure, but I'm not going to explain details of closure. Closure is the little bit bigger concept of the set. Set is, for example, SSN, for example, this is a set X. Closure X plus means any attribute that can be identified by the social security number. That means first name, last name, middle name, initial, last name, address, and so on. This information is called X or closure of X. X closure. So X closure is a little bit bigger concept. We will consider closure concept to compare the functional dependency because X determine Y, X derive the Y. So we need to consider such a closure concept. Using this one, there are some operations, then eventually we can define the functional dependency, minimal functional dependency. But anybody can understand? Why don't you explain to me? So I don't think that this is very difficult, but if you have a time, you can read. But this is not a math course. I'm not going to ask you to mathematically understand for you all of this, but simply this one is to find the core functional dependency that I explained. In other words, we try to remove any non-important data. For example, social security number plus the address determine first name. At that time, actually, address is not needed, right? So we will take out such a thing until we got the minimal information, core information. That is the definition of the minimal functional dependency. It will consider left and right. I tried to make my student understand this one in several years, but it's not very needed. So not many students understand this one, even sometimes more confused. So I think I try to just show the definition of the minimal functional dependency. So using that minimal functional dependency, you can find any the minimal functional dependency from any table. Okay, but I'm going to skip this part. So if you are interested to see the formal definition of minimal functional dependency, you can take a look at that. Let me know if you have any question. But it's the same process that you can intuitively find the minimal functional dependency. So I'm not going to use such a formal process to identify the minimal functional dependency, but intuitively you can find most of the minimal functional dependency. Then, so we have the minimal functional dependency. From now on, I'm going to use the term of just the functional dependency instead of minimal functional dependency. When I say the functional dependency of the table, that means it's a minimal functional dependency. Okay? Then, we discussed about the normalization process. Normalization process is to remove the redundant information. So what is the activity? We decompose. We segment the table. We split into two tables of the one table. Okay. Also, there is opposite direction of the normalization that is called the denormalization. I'm going to explain a little bit about the denormalization at the end of today's class. But simply, normalization is kind of a segmentation. You can split to reduce the redundant information. What about this one?
To put them together again.
You can combine, merge, put them together into one. Why do you need such a denormalization? Can you guess?
To do normalization again.
Why don't you think about it until end of this class today? Okay. Then, before we start such a normalization process, we are going to define some basic terminology used in the normalization process. That is the key. We have defined the key attribute in the entity relationship model. What is the key attribute in entity relationship model? It's a set of attributes that can identify the other data entity, right? How many key attributes can you have? Sometimes none, right? Why don't you think about the weak entity? Okay, sometimes one, sometimes two, sometimes more. That is ER modeling or the entity relationship model. Then, what about the relational database model? Among the key, we need to select one of them as primary key. How many primary key for each table? One. Only one. Always one. Even no non-primary key, if there is no primary key, that is not the relational model. Okay? Just like the file in your laptop without using DBMS. Okay? Even though you can create a table without primary key, that's not a relational database model, even though you are using the RDBMS. Okay? Primary key. Then, what about, for example, social security number and UBID in the student table? We can use a social security number. Also, we can use the ID, UBID as the primary key, but we need to select one of them as the primary key. The other key is called candidate key. Can you remember that candidate key in relational model? So this candidate key can be used for the primary key, but it cannot be because we need only one primary key. This is called sometimes the secondary key. Secondary key or candidate key. So any attribute, any column that belongs to either primary key or secondary key or candidate key is called prime attribute. All the other will be non-prime attribute. There are two types of attribute. Now, one is prime attribute. The others, non-prime attribute. What is the prime attribute? That belongs to either primary key or candidate key. If not, that is non-prime attribute. Have you ever heard about what is a prime? What about the prime number? What is a prime number in math?
The number that could only be divided by itself and
1, right? Why prime number is so important in math? Why? Have you ever think about? No, because you are not interested in the math. But why don't you think about one time? So on only one day or year, so March 14. So 3.14. That's not the prime number. Anyway, so prime number. Why prime number is so important in math? That is the fundamental of the number. So people, long time ago, so far, many people, especially the mathematicians, would like to investigate what is the basic element of number, math. Okay? Just like the chemical, the physics, or the other. So we'd like to know what is the basic element of the world, or natural life, the oxygen, or the H2, whatever. So just like that, in mathematics, what is the prime? What is the basic? What is the fundamental of the number? That is the prime number. Why? Prime number you cannot divide. In other words, using prime number, you can divide. You can make non-prime number. So for example, number 12 is 2 times of 3. Right? So this is a 2 to the power of 2 square times 3. Can you divide this number? No. 2 is prime number. 3 is prime number. So any number can be actually represented by prime number. So instead of the process this number, actually you can do prime number first. Then that's it. This is the same idea. So if we can find the prime attribute is the key attribute. The others can be derived from, inferred from prime attribute. So if you can identify such a prime attribute, that is one meaning, because you cannot divide such a prime, meaning of the prime attribute. So we will consider prime attribute and non-prime attribute. Prime attribute, what is a prime attribute? That is the attribute column belongs to primary key or candidate key. The others are non-prime attribute. Then, finally, first normalization form. First normalization form deal with only attribute by attribute. It's a very simple. Why don't you pay attention to just 5 minutes? Then you can understand most of the normalization process. First normalization form allow only atomic variable. Atomic variable. In other words, what are the examples of the non-atomic variable? Can you remember that? For example, multivalued attribute. Multivalued, you can decompose, you can segment multivalued one by value, right? Also, composite variable, composite attribute. For example, address consists of string number, string name, city name, state name, and zip code, something like that. So you can decompose. So first normal form does not allow such a composite variable. One, multivalued variable. What else? Nested. Nested means the attribute inside the attribute. Data inside the data. Just like the object-oriented concept. Because we are dealing with the relational database model, that does not allow nested inheritance. So, this allows composite, this allows the multivalue, this allows the nested. In other words, each value should be atomic variable. One time, I think the not one time. Last class, end of the last one, one of the students asked, is there possibility the database model? There's one database model and the others are connected using the foreign key like this. Yes. For example, if this column is multi-valued, we do not allow such a multi-valued one in first normal form. Instead, you need to segment that multi-valued column to another table. Similarly, you can do the composite variable like address by another. So at that time, you can have one main table and the others are connected by the foreign key. So because of this first normal form, what if you find such a multi-valued or composite variable or nested one? How can you solve the problem? How can you make the first normal form? Solution is just one. You need to decompose. You need to segmentation, like this one. You need to segment to decompose into another table. So when you find such a composite or multiple or nested attribute, you can decompose. You can segment, you can split into two. That is the first normal form. For example, the A, this is for department. Do you think the A department is in the first normal form?
No.
Definitely, final exam, we do not have a chance for makeup exam, okay? Also, you need to take another exam, at least 2 more exams during the final exam week. So sometimes if you are not lucky, you need to take the whole final exam in one day. So this is a good time. Definitely you will get at least 2 or 3 questions from this class, today's class, from final exam. Okay? So to save your time, why don't you pay attention? So first one is a department. Is it the first normal form or not? What is the first normal form? If the table is in the first normal form, all attributes should be atomic. Atomic means no multi-value, no composite, no nested. What about the D name? D name is the atomic variable? Yes. What about the D number? Yes, this is just number. What about the manager social security number? Yes, it's the atomic variable. What about the D locations? You can see the S. Plural, right? It's a multi-valued one. So you cannot create the table with the multiple variable like the New York, Dallas, and LA. No. Unfortunately, relational database model cannot handle such a multi-value. It's not in first normal form. We need to address that problem. Okay? First, then next one. This is the example. Yes, there are examples. Because of this, we cannot do that. How can you solve the problem? The only solution is decompose. That means we need to take out the location. Okay? So we need to take out the D location so you can make department and D location table. Why don't you take a look at your handout that I handed out long time ago for the company. It has the D location table. Can you remember that? That is actually caused by this first normal form. So you can take out this. What about this? This is another solution actually. D name and D number, but we have the primary key with the composite primary key, which means D number plus D location is the primary key. So you can see that this one. D name, yes, atomic. D number, yes. D name is a social security number. D location, yes. This okay. So this one is in the First normal form. This is another solution. You can do that, but it may cause later problem. So the best solution is take out the D location, then connect to the origin. That is the first normal form. It has the redundant information. The next one. A more example about the first normal form. What about the A? A is the EMP_PROJ project. So you design the company database like this one, employee project. But project has P number plus hours. That is nested. Okay? Actually, it's not allowed in relational database model, but we suppose that we have such a thing. So do you think that this is the first normal form? No, because it's the nested. We cannot handle in relational database model. That is not. This is the example. So because it has the nested, the relation, nested table inside table. Actually, right now, many of the relational database management system allow such a nested table, nested relation. That is called ORDBMS. Object Relational Database Management System. So most of commercial relational database management system right now you can see they are object relational or object relational database management system. The reason is that many people complain. Our modeling, we are using UML or object-oriented model concept. And also, we are using the object-oriented programming language, Java or the C#.NET and Visual Studio, and so. But database is still relational model. There are problems, there are gaps between your modeling, your programming, and database. So many, for example, our model, UML modeling, allows such a nested relation. My program also can handle such a thing, but database is the only one that cannot handle this one. So, can you provide object, DBMS, but the commercial vendor, such as Oracle Informatics DB2, they don't want to be risky to change. You know, who is the first market share company in the database management system market, DBMS market? Oracle. Oracle actually take almost half of the market. Then the other half are actually shared by Microsoft and IBM. Informatics also belongs to the IBM. It's merged to the IBM several years ago. But each DBMS has their own characteristic. For example, Oracle very good for online transaction, while the SQL Server is good for Microsoft family product. Okay, like the Windows-based server. While Informatics and Sybase are very good for data warehousing. Okay, and DB2 is for mid-range server. So they don't want to be risky to change their model. If they want to change the database model from relational model to object-oriented, it's totally new market. So they want to keep their benefit, but just add object-oriented concept a little bit, but which is not actually object-oriented concept. For example, in terms of object-oriented concept, it should have the object ID. It's not the set, it should be object, but there's no OID concept, object ID concept in database. It's just allow such a user-defined data type. User-defined user-defined data type. So user can define the data type just like the object, or allow this kind of thing. But traditional relational model does not allow such a thing. So it's not in first normal form. So we need to address that problem. How can we address that problem? We can segment like the employee project 1, social security number, determine E-name. This is for employee information. Another one is the social security number, P number, determine hour. This is work zone. One more? No? Okay, here. So we can make the first normal form from unnormalized form. How can you do that? If you can find multi-value, if you can find composite, if you can find nested, you can decompose. You can segment. Second normal form. Second normal form. Second normal form does not allow partial dependent. What does that mean, partial dependent? For example,
It's weak entity.
weak entity? No, weak entity is the concept in the ER model when you do not have the key attribute. But partial dependency means, for example, social security number determine DN. So, social security number plus DNO determine D name. Okay? Let's say this is a minimal functional dependency. However, actually, DNO is enough to determine D name, right? So D name is actually partially depended by the DNO. This is called partial dependent. Why partial dependent is the problem? Because partial dependent means it's different meaning. So second normal form allows only full dependency. In case you can find the partial dependency, it is something problem, redundant information. So we need to address that problem. So for example, what was this? For example, social security number, P number, determine hour. Is it a full dependency or partial dependency?
It's partial.
Partial, how can you identify the hours? You should know employee. You should know which project that employee works. So you should know both of them. So it's a full dependency. However, social security number and P number determine E-name, employee name. Is it partial dependency or full dependency? It's a partial. You need only social security number. That means this one has something redundant information. There are two meanings. One is work zone, another is employee. So we need to address that problem. How can you solve that problem? How can we make that relation as a second normal form? Decompose. Solution is only one, decompose. So we will see the real example. So I model the company database like this one. A, employee underbar project. As we have seen before, how many functional dependency, minimal functional dependency can you find from A? How many minimal functional dependency? 3. One is social security number and P number determine hours. Okay. Functional dependency 2 is social security number determine E name, employee name, and P number. Third one is P name determine P location and P name. P number determine P name and P location. Then, first, is it the first normal form?
Yes.
What is the first normal form?
Not first because it's composite.
Which one is composite?
Nested relation.
Which one? P name is atomic. Okay.
P location.
P location is a 1. Okay? It's not plural. Any composite, any multi-value, any nested? No. So, in other words, this is a first normal form. Then second, you need to check the second normal form. Is it the second normal form?
Yeah.
What is the second normal form? Only full dependency. For what? Non-prime attribute. For the non-prime attribute, whether this is partial or full dependency. So second normal form allow only full dependency. Okay, check. What are the non-prime attributes in this?
name,
Hours, e-name, p-name, p-location. P-number and social security number are prime attribute because they belongs to key, primary key or candidate key attribute. So let's check. Hours. Hours is determined by what? Social security number and P number. Is it full dependency or partial dependency? It's a full. It's okay. What about e-name? E-name is determined by only social security number. It's a partial dependency. Okay? So that's not in second normal form. What about the P-name and P-location? It's determined by only P number. It's a part of prime attribute, right? So it's not in second normal form. So this EMP underbar project is not in second normal form, but it's in the first normal form. How can we make the second normal form? Decomposition. Solution is just one. Decompose, decompose, decompose. How can we decompose? Take out this part. So P number determine P name and P location. One table. And SSN determine E name. So you can take out this one. One more thing is actually this one is a foreign key. This one is a foreign key. Okay? Do you understand? So in this example, I do not put the foreign key, but actually you need to add the foreign key to keep the data consistency. Okay? To keep that relation. Okay? So this is the second normalization form. Second normalization form is only full dependency. So first you need to identify the minimal functional dependency from the table when you are doing the normalization. Then check non-prime attribute. For each non-prime attribute, it should be full dependency. In other words, what if you have only one prime attribute?
this one have just one?
Yeah, just one prime attribute. This is already the second normal form. Do you understand what I'm saying? Because it's just one attribute. It cannot be part. It cannot be partial. So in case you have the one prime attribute, okay, most of the cases, many of the cases, one prime attribute, it's automatically second normal form. So that's another trick. Okay. The next one is the third normal form. Before we move to the third normal form, in set theory, in your math, can you remember this kind of the operation? So X determines Y. Y determines Z. In other words, for example, Fx and G, Y. This means actually Z equals, right? You can just plug in Y into this one. In other words, X determines Y. Y determines Z means X determines Z. This is called transitive. This is a transitive property. So it's obvious. Everybody knows the transitive. So we are going to consider such a transitive. Okay. Transitive in functional dependency. So, for example, first example, social security number determine D manager social security number. Actually, social security number determine D number. D number determine D manager social security number. Does it make sense? Okay? Yes, this is from employee. This is from department. So, however, if you have such a social security number determine the manager social security number in one table, one relation. This is called transitive functional dependency. In other words, actually this one is go through the number. What about the social security number determine e-name? It's a directly determine e-name from social security number. You cannot find any in-between attribute. So that is non-transitive attribute, or non-transitive functional dependency. Then, third normal form actually does not allow such a transitive functional dependency. Why? Why? What are we doing right now?
It's redundant.
We are trying to find redundant information. In other words, sometimes we can say redundant information as two meaning, one table, or functional dependency. So, in case you have transitive, like this one, it's a set of attributes, set of attributes, set of attributes. In other words, we have two different meanings in one table. If you have transitive functional dependency in your table, that means we have two different meanings. So we'd like to address that problem. How can we? The only solution is decompose.